Hello everyone. Today I'm going to show you how you can take fine-tune model with different LoRa adapters and deploy it in a production setting, track all the matrices using Prometheus, and deploy it in a very optimized manner by including continuous batching, multiple adapter serving, and KV casing. So all the load testing we are going to do today is on this cloud instance. So I'll show you. So if you see, I have an NVIDIA 10 GPU with 24 gigs of memory. So everything we are going to do is on this instance today. So I have three different load testing over here. So mainly they're into two categories. One is more like a throughput and latency test, and one is more like a latency test. Within the latency test, I have like two different paragraphs, two different sizes of input. One is like a much smaller one. This one is like a very smaller one. If the paragraph is not as big, it's just this much. And then I have like a much bigger paragraph. And this is the benchmark test, which has the throughput and latency test, which is like quite a bit of variation. So let's start copying it to the CLI, right? Right. So as I said, this is the server that I'm running. I'll show you how I used like a pre-built documents to do this. You see, this is like a much bigger paragraph, as I told you, and this is like a smaller one, and this is the throughput test, right? So let's run them one by one quickly. And then this is this. I'm not sure, this is some lag over here. Okay, things started running. So let's see which one will finish fast. Yeah, so this one finished first, which is like quite expected, right? This was like a much smaller input and output. So we sent 50 requests and we completed 50 requests. Okay, so before that, I will go over to the parameters that we use. So I used 10 concurrent users, 5 requests per each user, and like I kept the total number of requests to 50 requests. Right, again, then for the bigger one also same. I'm waiting for this much 20 seconds, but if we get faster response, we don't need to wait as long. And yes, so let's move it to the result. Right, yeah, this is a much smaller input, right? So you see 50% of the users got their response within 9 seconds, and then like 20 seconds, which is like the longest request, right? And for the bigger one, we have like a big jump over here. If you see, 50% of the users received their 37 seconds. 90% of the user got their answer within 40 seconds, which is not as bad, because if you think we will be printing, word by word. If you think of talking to ChatGPT, it will print word by word, right? So in 39 seconds, there are a lot of word coming in. If you see the output was 256 or something, it will have a lot of, words in the reply. So, I mean, it's still kind of big, but yeah, I mean, 39 seconds, like 90% of their answer in 39 seconds. And this is the throughput test, right? So let's see. So inter-token latency is how much time you took between printing two words, right? Think of ChatGPT prints, word by word, right? So time difference between two consecutive words is like the inter-token latency. So it's 1/10 of a second, right? And time to print the first word. So it printed first word within 2 seconds for like a lot of like 50% of the user. Basically, you will see the first word within 2 seconds, right? And not to mention, it was dealing with like all these two requests as well, right? So this was like 10 concurrent users, 5 requests per second, and then 10 concurrent users, 5 requests per second for like two different, one is a smaller and bigger this thing. And I think the first word is quite well, but you see one of the P99 is 4 seconds. So there are some user, like maybe like less than 1% of the users, some of them saw the first word within 4 seconds, like after 4 seconds. End-to-end latency, it took like 49 seconds. 50% of the user got their answer within 50 seconds. 90% of the user got their answer within 52 seconds, which is not bad given that you're streaming like word by word. And yeah, throughput, tokens per second. So this is like how many words we are printing to the chat UI per second. So if you see, almost 50% of the users seeing 9 words per second, right, in their UI. And then some of less than 1% of the user are seeing 10 words. And you see, there is a lot of variation in the input tokens, right? So as I said, the input tokens is basically the queries you asked. So it took like a smaller query of 120 words. 25% of the time. There is a 0.5 over here, so it's and then 50% of the times you sent 307 tokens, almost 307 tokens, and mean is 299. You see, number of output tokens are 500. It's much longer, right? So the answer is much longer, 500 tokens. So yeah, you can take all of these numbers through this benchmark test and then tune according to your service level objective. When we were doing the throughput test, we saw that we were getting roughly about 11 to 12 tokens per second. So let's see what that looks like in terms of the chat UI. If you see, this is around 11.45 tokens per second, so it's not really that bad, right? So now I will show what is the server that I used. I used a server from a company called Predibase. So they open source their server, so you can just give, you can serve multiple LoRa adapters using their server. This is their repository, right? And I used Ray. You must have heard of this. Is like a very popular. They are a very popular company, so for distributed training and stuff. So you see, I used LLM prep for the benchmarks to run the throughput benchmarks, this one, and the LoRa docs, right? So they have like a really nice docs. I used their Docker image with my LoRa adapter and my base model and LoRa adapter. So you can serve multiple LoRa adapters through this. So if you see the reference, so in the request, you can just pass the adapter ID so that you can, within the same deployment, you can serve different fine-tuning models. You don't have to make multiple deployments, right? Hope you liked my demonstration. Thank you for watching.